All right, today we're going to be talking about our triangle inequalities and theorems. So let's get started here. This is important information to know. So for your triangle angle side relationships theorem, that's saying the smallest side is across from the smallest angle. And the largest side is across from the, or excuse me, this should say the largest angle. There you go. All right, so the largest side is across from the largest angle. So if you're looking over here, notice this is the smallest side. That's going to go with this angle. So we know this one goes to that because they are across from each other. Now, if you were to look here, we know 5 is the middle, and since this is the middle length, that's going to go across, so that's going to be the middle angle as far as size. And then 6 is the largest side, so that's going to be the largest angle. So if you were to put them in order from shortest to longest, AB is 4, and that goes with C, and it go on, and then AC is the middle, and it goes to B, and then BC goes to A. All right, so that's important so you can order things. All right, so let's look at example 1. It says list the sides and angles in order from shortest to longest. So first we need to figure out what the angles are. So we're going to take the 3 interior angles and we're going to add them together. And we're going to equal them to 180 because that's how many angles or degrees are in a triangle. So once you go ahead and you simplify this, you're going to get x equals 8. Now that we know x equals 8, we're going to substitute that in for each x here to find the measure of each angle. So angle A, 7 times 8 plus 6 is 62. Angle C, 7 times 8 plus 8 is 64, and angle B is 8 times 8 minus 10, which is 54. So now that we know this, 54 is the smallest, so that's the smallest angle. Now, if this is the smallest angle, that means that AC is going to be the smallest side. The middle angle is going to be 62, which is A, and we know that angle A is with BC, so that's going to be the middle side. And then lastly, this is the largest measure, and that's going to go across, which is AB. So angle C is across from AB. All right. You're going to try that one, and again, it's going to be shortest to longest, and it doesn't have a triangle, but you're welcome to draw a picture, and then go ahead and put those in order. All right, next up is the triangle inequality theorem. So that's saying the sum of any lengths of any two sides of the triangle is greater than the length of the third side. So basically, the sum of the two smaller sides is greater than the length of the third. So all you have to do is just add the two smallest sides together. If it's greater, it's a triangle. So here we took 5 and 7. Those are the two smallest. Are they greater? Is the sum of those two greater than 9? Yes, because you have 12. So this is a triangle. So now let's go to the next example. I'm going to take 3 and I'm going to take 1, add them together. Are they greater than 8? 4 is not, so that's no. All right, you're going to try those two, and this one is a trick one, so be careful. And then now we're going to talk about finding the range of the third side. So remember, we're saying it could be any of these numbers between. So the third side has to be larger than the other two sides subtracted. So that's the minimum length. That's the smallest it could be. And then the other part of the range is it has to be smaller than the two sides added, which is the maximum. So basically, when you're doing this, it's saying that you have to have one side has to be in between. So this is the small, this is the larger size, and your third side needs to be between there. All right, so here's an example I started for you. So what we're going to do is you're going to take your two numbers and you're going to subtract them. And in this case, I got 5, so that's going to be the smallest length the third side could be. And then to figure out what the maximum could be, now we're going to take your two numbers and add them, and then that's going to be the longest that it could be. So your third side is going to be somewhere between those two. All right, go ahead and try those. And then now we're going to talk about the exterior angle theorem. So the exterior angle theorem is saying if you were to solve this, measure of angle 1 is 132 degrees, so that's this guy. And the measure of angle 2 is 60. Measure of angle 3 is 72. So if we were to go measure of angle 1 plus the measure of CAB, this is what we're looking here. So those two together are going to give you 180 degrees. If we were to also take the measure of angle 2, measure of angle 3, and CAB, that's also equal to 180 degrees. So the shortcut, or the exterior angle theorem, is if we were to take the measure of angle 1, that's going to be this is this plus that. So your measure of angle 1 is going to be equal to angle 2 plus angle 3. So whatever is outside the triangle is going to be equal to the sum of the remote opposite, or the remote interior angles. So the measure of the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So like I said, you have D is equal to A plus B. All right, so I want you to try these two by using the exterior angle theorem. And then I'm going to just do this example for you right here. It says find the value of x. So we know, since this is the exterior angle, I know that 11x plus 2 is going to be equal to that plus that. So we've got 5x plus 10 plus 58. And then when you go ahead and you simplify, you're going to get x equals 11. So you could do a shortcut and find this one and then take it all away, but this is actually the shortcut for it. All right, so you're going to go ahead and you're going to do the same thing here. And remember, this is going to be that plus that. So go ahead and solve for x. All right, another triangle theorem is if in an isosceles triangle, the angles across from the congruent sides are also congruent. So remember, we said that the angle that's across from the side is associated with it. Same thing here. But since these are, since these are equal, that means that your angles are also going to be equal. Because this is here, if that's the same, then that's the same. All right, equilateral. All your angles are going to be 60, because if you were to take 180 divided by 3, you get 60 degrees. All right, so let's do a couple here. For this one, you got a couple steps you need to do. So first off, we need to find x. So I'm going to go 65 plus 90 plus x is going to equal 180, since that's the interior angles, or it's how many degrees are in a triangle. And when I solve that, I'm going to get x equals 25 degrees. All right, but to find y, if you notice, this is a right triangle. So we can use Pythagorean theorem, which is a squared plus b squared equals c squared. And remember, c is always across from your right angle. So go ahead and you would put that in, and then you would get 5 equals y. All right, on this one, I know it's equilateral because if you look here, all the angles are the same. And if it's equilateral, each angle is going to be 60 degrees. So this is the same as 60, so that's why we did 5y equals 60. So we know y is going to equal 12. And then now for the sides, if this is an equilateral, all the sides are the same. But we only need to find x, so we can use those two sides. We don't care about the third side in this case. But I know this side is congruent or equal to that one. So we're going to go 3x plus 2 is equal to 5x minus 6. And again, solve that, and you get x equals 4. All right, I want you to go ahead. You're going to try these three. I'm going to do this last one for you down here. It looks tricky, but it's actually pretty simple. Because if you notice, you have three triangles, but that's an equilateral triangle. That's an equilateral triangle. And that's an equilateral triangle. So all of these are equilateral triangles. If you wanted to get and go ahead and write all that down, you could. You don't have to. But I do know, since it's equilateral, that's going to be 60. Now, again, since it's equilateral, all the sides are the same. So I know this side is congruent to this side, so you just equal 4x plus 40, and x equals 10. So go ahead and finish the others on the page, and then that is your triangle inequalities and theorems.